Hello, developers. In this video, I will be going over on how to make a simple directional animation system with just one animation. If at any point you have some trouble or an error, you can ask me in the comments section or join the Discord server in the description for help too. Without further ado, let's go straight to the tutorial. First, we'll need to set up all the things we need. Follow my steps. We'll need to add a script in Server Script Service. After that, we'll have to add a remote event for sending the server the information it needs to replicate to all other players. Then after that too, we'll need a local script. And then for the final thing, we'll need the animate script. To do this, you'll have to press play first. Open your workspace and open your player name. In there, you'll see a local script named Animate. Right-click on that and press Copy. Now, stop the game and paste it into starter character scripts. To do that, press right-click and then press Paste Into. Voila! You're done with the setup. Now get ready. Because we are about to start scripting, go ahead and open your local script you made in starter character scripts. First, we'll need to add all the necessary variables. You can customize these variables below the settings comment. It's really just a process of trial and error to see what values are the best for your game. We'll use 45 degrees for the range of motion for now. Now we can start with the main code. We'll need to convert all the range of motion variables to radians first. Now, the main run service code. All the math and some of the replication will be here. Get ready for a yap session. First, we'll get the direction of movement relative to the humanoid's root part. To get that, we'll need to use the vector to object space function from the humanoid's root part C frame. Every C frame has this function and a ton more. After we do that, we plug in the humanoid's root part assembly linear velocity. The assembly linear velocity of the humanoid's root part is originally in world axis. With this function, we are converting that to the humanoid's root part direction, so we know if the humanoid's root part is moving right, left, or any other direction. And then after that, we'll remove the y-axis and divide the x and y velocity with the humanoid's walk speed. The reason I don't just use unit is because it behaves weirdly if your movement is smooth. Now, we calculate the x result. To do this, we'll multiply the x velocity with the range of motion variable, and that results a number between -45 degrees and 45 degrees. That range of motion variable is then subtracted with the absolute value of the z direction. We multiplied the z direction with the range of motion variable that was divided by 2. We'll make an if statement. If the player is moving backwards, we multiply every x result with -1. Note that the humanoid's root part is actually facing backwards, so we use a less than operator and not a greater than operator. Now, the hard part. The legs are the hardest to make. Roblox made the legs complicated because their motor 6D connection is not in the center. I do not know why, but we have to make do. We make the legs C0 C-frame to the original leg C0. And then we multiply that with a new C-frame. The new C-frame has X result 2 because the X result 2 is the variable that sets how far to position the legs. You could entirely skip the C-frame.new step and skip to the C-frame.angles if you set your motor 6D connection to the center. But if you already have animated a lot with your game, well, I don't recommend doing it since it changes the legs, so your animations might look off. After that, we multiply that new C-frame with an angles C-frame, and then we put the X result variable to that. Now just copy that and make sure to change the first math.a, b, s value to minus. Now we set the root joint, which connect the torso and the humanoid's root part to the original root joint C-frame, and then we multiply that with an angle C-frame, which has the X result torso variable. It's the same with the neck C0, but it doesn't have a negative at the X result torso. Now we'll set all the C0 to the results. We'll do this by using the built-in lerp function from Roblox. We set the time function to 1 minus the lerp speed to the power of delta time. I made a mistake here, and you should change the star symbol to the up arrow symbol or circumflex, or the alternative 6 symbol on your keyboard. Now, we'll need to copy over the run service code to the animate script. The reason we need to change the animate script is because we need to make sure if the player is moving backwards, the walking animation is reversed. Make sure you change the animation ID to the walking animations ID. We're almost done, but let's test it out. Okay, now we only need to replicate it to other players. We'll make a while loop in the bottom. Every 0.25 seconds, we fire off an event and we pass the results to the event. You can change the duration to however you like, but I don't recommend going below 0.1. Now go to the server script. We'll catch the remote event here and we pass the variables to the other players, including the player that sent the event. Now, we'll go back to the local script and then we catch the remote event sent by the server. We get the character first, and then we'll make a table inside the player's table so we can keep track of who the player is. Now we'll loop through every player and then set their C0 using lerp. We'll need to make sure that if the player leaves or doesn't exist anymore, we should remove them from the table. We're finally done. Unfortunately, my recording software doesn't support recording multiple tabs, so I unfortunately cannot show the results on 2 players, but you can test yourself by using the Roblox 2 player test feature. Anyways, if you watched till the end and liked it, please like the video. In the next tutorial video, I'll be showing about how to make procedural walking on Roblox with inverse kinematics. Subscribe to get the notifications if a new video does come out. Anyways, thanks for watching. Bye!